are given a series of ordered pairs of points that belong to a polynomial, you can actually construct the single equation for the only line that goes through those points. For example, I've got an example here where I have 6 data points, 6 ordered pairs on a graph, and we were asked to create or find the only equation of the polynomial that runs through all 6 points. The very first thing we need to know is, what is the degree of this polynomial? Is it a degree 2 quadratic? Is it a degree 1 straight line? Is it a cubic? Is it a quartic? A degree 4? A quintic? Degree 5? And a finite difference table can answer that question for us. When we construct a finite difference table, we take our ordered pairs, our x and y pairs, and we put them into our table. Now, the ordered pairs need to be sequential. So what that means is their x values, you can see it's sequential, -2, -1, 0, 1, 2, 3. They need to be in sequential order. They don't necessarily have to be 1 apart. They could go 2, 4, 6, but they need to have a predictable sequence. And we put them in our finite difference table. And what we do is we start finding the difference between these points. The first difference, the first finite difference, I ask myself, how did I get from a -37 to a 2? Well, I have increased by a value of 39. From a 2 to a 5, I have increased by a value of 3. From 5 to 2, I would have decreased by a value of 3. From 2 to -49, I've definitely gone down. I've gone down to 0 and then down to another 49, so I've gone down a total of 51, so a decrease. -51 is my difference between those 2 points. And then from a -49 to a -262, then we know that we've gone down -213. Now this is my first difference column. Had I got a constant in that first difference column, I would know that I have a linear function, a straight line. I don't have a constant in that first finite difference column, so I keep going. I say, well, it's not a straight line, it's not a linear function, but what is the second difference? And then if that's not a constant, I do the third difference, and I keep on going until I find the value showing up as a constant in that difference table. So what I would ask you to do is to pause the video, continue finding where you get a constant in that finite difference table. Okay, so hopefully what you've done is you have completed that chart and found that, oh, I get a -72. No constant in the third column, so this is not a cubic. However, I do get a constant in that fourth column, and if I had some more data points, we would get -72, -72, -72, all the way down. We can conclude from that since I got a constant in that fourth difference column, it is a 4th degree polynomial or a quartic polynomial. So what I then do is I start building a framework for that quartic polynomial. And I start with a general equation. So the general equation of a 4th degree polynomial, and I'm going to use equation form, so y equals, now I would have the highest term to be an x to the exponent 4, but I can have a coefficient in front of there and I don't know what it is yet. So we have a placeholder, let's just call it a. And then I could have a placeholder or some number in front of a term of x cubed, some number, let's call it c, in front of an x squared term. I could certainly have an x term with some number, and finally I could have a constant at the end. And so I have built a framework equation, and I need to know what are the 5 specific numbers that go in those spots so that I can know the single equation that goes through those points. Now notice that I have 1, 2, 3, 4, 5 unknowns, and I'm going to stress this. Since I have 5 unknowns, I am only going to use 5 points. I've been given 6. I don't need all 6. If I have 5 unknowns, I will use 5 points to build 5 equations that I will then use with substitution or elimination, or sorry, I'm going to use elimination then substitution to find out what those mystery values are. If you're given more points than what you need, don't use them. It just becomes cumbersome and it gets all confusing. So how do we use those 5 points? And which 5 points do we use? Well, they need to be sequential. So you could use the first 5 or the last 5, or if we had more, you could use a middle center of 5 that are in a row. Just to make it easy, I'm going to use the first 5 that we were given. And so I will use my XY pairs. The first XY pair I have is a -2 and a -37. Of my XY pair, my Y value is a -37. So I would substitute it in for that Y value is equal to, and then this -2 is my X value. My X value is going to be to the exponent 4. So a -2 to the exponent 4 is going to be 16. A times 16, we would more be apt to write 16A. If I cube that X value, I'll get a -8 with my B. If I square that -2, I'll have +4 with my C. If I have my X value, which is a -2 times my D, then I would have -2Ds. And finally, I would have this E at the end with no X being multiplied. Similarly, I will do that with all the rest of my points, a -1 going with a 2. And so my Y value is a 2. My X value is a -1. -1 to the exponent 4 would just be 1. And I know that we normally would not write this, but I'm going to ask you to keep it as a placeholder so that we can keep it there and keep track so that when we're subtracting values, it just makes it a whole lot more simpler. Trust me on that one. If I have a -1 and I cube it, it will be a -1, so I'll have -1 of these B's. If I square it, it'll be a +1, so I'll have +1 of these C values. And then finally, I will have a -1 of these D values plus my E. Using the next point, a 0 and a 5, I will use my 5 for my Y. And 0 to the exponent 4 is 0. So I would have 0 A's. And normally I wouldn't write them. But I'm going to ask you to keep it there as a placeholder. You'll see why later. It just makes a future step a little bit easier. I would then have 0 cubed B's. So adding 0 B's. 0 squared, I'd be adding 0 C's. 0 times my D, I would be adding 0 D's. And I'd have this E. Now I'm hoping that you notice here that we actually have one of our mystery values here. If I have 5 is equal to 0 plus 0 plus 0 plus 0 is equal to that E, then I can say, hey, I know one of them now. E is equal to my 5. And so in my mystery equation, I know that it has a y-intercept of 5. Right here, there it is. If I go over 0, I'm up 5. And so my last final value is right there. And we'll put it into our chart with a bunch of 0 coefficients so that it'll be easy to do our elimination later. And then we're going to do the same thing with our 1, 2, and that's 1, 2, 3, 4 points. I need 5 points. I will do it with my 2 and my -49. So what I would like to ask you to do right now is to pause the video and create those equations, and then we'll move forward. Okay, so hopefully you had no trouble building those last 2 equations. What we do now is we will take this bank of 5 equations and start subtracting them from each other. To make it a little more organized, let's call this equation 1, equation 2, equation 3, equation 4, and finally equation 5. And what I'm going to do is I am going to eliminate that last variable, my E, by doing a series of subtractions. And so what I'm going to do is I'm going to take, and I always start from the bottom, I just think it's easier. I'm going to take my fifth equation and subtract all the values of my fourth equation. So my fifth equation minus my fourth equation. And so I look at that and I say, okay, well, my fifth equation has this constant of negative 49. So a negative 49 minus that negative 2 will be negative 51. 16a's minus that 1a will be 15a's. 8a's minus 1. 4c's minus 1, 2d's minus 1d, and I get that 1d left at the end. An e minus an e, those e's are eliminated. And then, once I have subtracted those two equations, I will subtract the fourth and the third equation. So, my fourth equation has a 2. 2 minus that 5 is negative 3. 1 minus 0, oh, that's still going to be 1a, and keep it as a placeholder. 1 minus 0, again, 1 minus 0 c's, so 1c, 1d, take away none, I have 1d. My e, take away e, it is eliminated. Finally, I'm going to do those same steps for my third equation minus my second equation minus my first equation. And so what I'd like you to do is, again, pause the video now and see what you can do to create those last couple of equations in that equation bank. I'm hoping that you came up with a 39 minus 15. So we've got our second equation here, number 2. A 2 minus 37, so 2 minus a minus. So 2 minus a minus would be 2 plus that 37 for a 39. Be careful with your double negatives. 1a minus 16 would be negative 15. Negative 1b minus a minus would be 7b's. Negative 1b plus 8. 1c minus 4 would be negative 3c's, and negative 1d minus a minus would be negative 1 plus 2 would be plus 1, and an e minus would be eliminated. Now, please take your time through these steps. If you make one silly glitchy error with your double negatives, or one of these numbers is wrong, then we're never going to find what our a value is worth accurately. So please take your time, use your calculator, that's what they're there for. Use that security blanket so that we don't make any silly errors. The next thing we're going to do is eliminate our d variable. You can see that I've labeled these equation 6, equation 7, equation 8, equation 9. And so what I would ask you to do right now is to spend some time doing elimination with our 9th and our 8th. And then eliminate our 8th minus our 7th, our 7th minus our 6th. So pause the video now, take some time, get some practice on that, and see if you can subtract your 39 minus your 3, negative 15a minus a minus 1. All right, hopefully you have that as a 10th equation, that as an 11th equation. Notice I have left my 0 placeholder here. When I'm subtracting the 8th minus the 7th equation, I get 1b, take away 1b, keep it as a placeholder, 0b's. Finally, we'll label them 10, 11, and 12, and our last step is to eliminate the c. Well, not last, second last step actually, eliminate the c. If you eliminate your c value, what you're going to be doing is taking your 12th minus your 11th, and your 11th minus your 10th. And so my 12th, 48 minus the 6 is 42. Negative 14a minus a minus 2, I'm going to get negative 12a. Negative 6, take away nothing, is still a negative 6. Negative 2c minus a minus, so plus 2c, my c's are eliminated. And finally, I get 6 minus my 36 for negative 30. 2 minus a minus 14, so negative 2 plus 14 for a positive 12a. 0 b's minus 6 b's for negative 6 b's. And finally, I will label that 13 and 14 for my equations. And I finally get to eliminate that last b variable by subtracting my 14th equation from my 13th equation. Sorry, other way around, 13th from 14th. Negative 30 minus 42 is negative 72. 12a's minus a minus would be 12a's plus 12a's for 24a's. Negative 6b's minus a minus, so negative 6b's plus, and my b's are gone. And then I can say, let's solve for a. If I have negative 72 and a 24, I will be dividing that 24 away, and a is solved to be a negative 3. What do I know now? I know that from my mystery equation that goes through these 6 dots, I have a negative 3, x to the exponent 4, and I know that I have that 5 at the end. And so now our job is to figure out these last 3 unknown values. And so down here, hopefully you've got some room, I'm going to go way up to the top and start doing some substitution. If I know that a is a negative 3, I am going to substitute in an a of negative 3 into one of these equations somewhere in my equation bank that will allow me to find another letter. Where it is down here. I have 2 equations down here that just have an a and just have a b. I can pick either of them, either equation 13 or 14. So into either 13 or 14, doesn't matter which, you'll get the same answer. I just usually pick one that has the easiest numbers. I guess it doesn't really quite matter here. This is a positive value, so perhaps I'll use 13. And so my 13th equation is a 42 is equal to a negative 12 times that a, so I now know the value of a, it's a negative 3, minus 6b's. That's my 13th equation. So I get 42 is equal to a 36 minus 6b's. 42 minus 36 is equal to negative 6b's. And so I have that 6 is equal to negative 6b's. 6 divided by that negative 6. My b value, I've got it. It's a negative 1. So we know that negative 3, yep, negative 3 x to the exponent 4 minus 1x cubed, so I just say minus x cubed. I don't know my c and don't know my d. And so we are going to substitute in. If I know that a is negative 3 and b is negative 1, I can sub that into any of the equations that allow me to know just one mystery value. I know my a's, know my b's. I can use one of these equations to calculate out c. It truly doesn't matter which one you choose. I would probably choose the one with the littlest numbers and the 0 in here. So I'm going to choose 11, but we could do 10, 11, or 12. And so sub that in there, and let's see what we get. So pause the video, pick one, doesn't have to be 11, and away we go. Hopefully, you have put it in successfully and found out that your c value is 0. What does that mean? It means I don't have an x squared term in my final equation. So let's barrel on through. I know that I need to substitute these known values into an equation that will allow me to finally find my last mystery unknown, d. So I'm going to choose any one of these in my bank of equations. Which one will I choose? Probably the one with the smallest numbers and the least amount of negatives. But we're going to substitute an a of negative 3, a b of negative 1, a c of 0 into either 6, anywhere to 9. Any of those equations will allow you to be successful in finding the value of d. So pause the video, do that now, see what d is. All right, did you get a D of 1? If not, take a peek at where you went wrong. Any one of these equations would allow you to put the A, B, C value in there and calculate a D of 1. We already knew that E was 5, and so I can make that final statement that my A value in front of my x to the exponent 4, my B is a negative 1. I don't have a C value, so I don't have an x squared term, so I wouldn't write it. If D is a 1, then the D in front of that x position means that I have 1x, and we knew the 5 from the beginning. This is the single equation of a polynomial that travels through those 6 original data points. We find out what degree we're working with, build a general equation, figure out how many unknowns do I have. I use that many points to build that many equations equal to my number of unknowns, and I build a series of equations using my data points, my x and y data points, and then I start subtracting. I eliminate my last variable sequentially by subtracting the bank of equations. Once I finally have that leading coefficient, we don't always know a point. It's only if I have a 0 data point in here with an input of 0 that I'll know my final y-intercept value. Sometimes I'll get here and I'll only know an A, but I do that sequential substitution into my equation bank, and finally I find my final equation. So I have a set of values, or a set of data points and their answers that you can have some fun with.